All right, today we're doing a very similar thing, but the difference is this time we're trying to find missing angles instead of just missing side lengths. So if I have my triangle set up like this, we're going to do the exact same process we would last time where we label it and actually solve. So this is my angle. So this is going to be opposite, hypotenuse, adjacent. I'm obviously using opposite and hypotenuse, so I'm going to set up a sine ratio. So sine of x is equal to opposite over hypotenuse, so it's going to be 4 over 8. Now, I can simplify a bit. You know what, let's leave it the same. This can simplify in this case to 1/2. A lot of times it'll simplify to some decimal or something. Leave it as a fraction, that's the best step. So I want x to be by itself, so I want it to be x equals. We talked about it before. If we want to get rid of sine, we have to do the inverse. So the inverse is sine inverse 1, and we're going to do it to the other side too. So it's going to become inverse sine of 4 over 8. Most good calculators, you can just type this in, inverse sine, bracket 4 divided by 8. Do that and it'll give you the answer. When I put it in mine, make sure you do the brackets, I got 30. Okay, and remember, this is where a lot of students forget, x that we're finding is an angle, so we're going to have to put degrees for our units. A lot of students forget this. I think it might help to, at the start of your question, just write like degrees at the bottom so you remember to do it. This works the exact same way, whether it's cosine or tangent. You fill in the numbers and then solve. I actually think this is a lot easier than calculating for side lengths. It's not too complicated. You just have to remember how to do the sine, the inverse sine. You're going to start encountering word problems where it's going to say angle of elevation and angle of depression. In both cases, from whatever it is you're measuring from, so like a person, whatever, you're measuring like a horizontal line through the air, as if they're holding their arm out flat in front of them. If it says angle of elevation, that means you go from that imaginary horizontal line and you go up. So in this question, I saw a balloon at an angle of elevation of 30 degrees. That means from my horizontal sight lines, I'm going to go up 30 degrees, and then that's where the balloon would be up in the sky. In this situation, I saw a boat at an angle of depression of 40 degrees. So again, you have your person, the horizontal line, the 40 degrees is going down this way, 40 degrees. And then you have a boat, whatever it was, and that's your right angle triangle. Being able to draw these triangles based on situations being described is one of the hardest parts of this unit, because hopefully the formulas aren't being very complicated for you. This is going to take some practice, but these words, depression and elevation, you need to be comfortable with reading and sketching pictures. This is tricky. All the triangles we've ever done this unit have been right angle triangles. This triangle right here is not a right angle triangle. It very clearly says in the question, it's not 90 degrees. But what you do see is that it is isosceles, which means that two of the side lengths are the same. Isosceles have a really cool property. You can cut them in half. So if I cut a line directly down the middle, like that, creating two 90-degree angles, these two triangles are actually identical to each other. We know they're identical because isosceles angle law says that this angle is the same as this angle. Okay? So I'm actually going to replace that with an x. Now, if we know this is x, and we know this is a right angle, this is something. These two also would have the same angle here because it's cut in half, and they all have to add up to 180. So if you get an isosceles triangle, you can cut it into two. And what's cool is it was 10 on the bottom, but we cut them into equal pieces because that's how isosceles work. So now we know those two lengths are 5. Now if we wanted to figure anything out, like the angles, okay, we need to know an angle first, so we can actually use a trig ratio to figure it out. So let's say we want to find x. Let's use this side and this side. This is the hypotenuse, this is the adjacent. So I'm going to use cos. Cosine of x is equal to 5 over 6, and I can solve. Okay, inverse cos, move it over. So it ends up giving you 33.56 degrees, whatever. Okay, now that I know this angle, we know this is the same. We can also figure out this angle because we know they add up to 180. And then, if we really wanted to, we could figure out the height of this line, either by using Pythagorean or by using a trig ratio, whatever. There's lots of options. The key thing is that when you have an isosceles triangle, you can cut it in half. You can bisect the triangle, make two triangles that are the exact same, including angles and side lengths, but only with isosceles, where you have two side lengths the same. Be careful when you have questions like this. This is not an isosceles triangle. It's just a scalene, borrowing all three sides different. Okay, so you could cut it down the line like this. The only problem is you don't know how long this is. When we cut the isosceles triangle, we knew that the two base sides were the same length because it bisects, because it's isosceles. This, we know these two are different, but we have no idea what they are. So this is some mystery amount, and this is some mystery amount. You just know that they add up to 8. In this case, it's not enough information to actually solve the triangle. There are questions where the triangle is shaped like this, where you can cut it into two pieces and solve, but it takes a little bit more work. And if you come across one of those, take your steps, take your time, do your steps properly, and it works the same way. And that's it.